CloudDB, shaping your new normal.
Hello, everyone. Welcome to the 2022 APEC Database Days by Apaco UC. This is our first year having a dedicated database event, and it's our honor and privilege to run this event with the support of 15 different Oracle user groups and jugs in the Asia-Pac region. Please remember to register to as many sessions as you can. This way you'll be able to have access to our replays until May 20 of 2022. Basically, how our works, you just need to go to the agenda of the event, register to attend as many sessions you want. Then you go to your attendee tab in the application, see your own schedule, and then you're going to see all the sessions you are registered to attend. The ones you miss, after 24 hours after the session, you will have there the link for the replays. I would like also to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Ace Community, the DevRel team, and your main sponsors, Oracle Corporation and CloudDB. Now for today's session, Data and Database Portability in Docker by Sean Scott. Please feel free to ask questions at any time by using the chat window on the application in the right lower corner of your application and your screen. And Sean will be answering your questions by the end of the session. If you have any issues during the presentation, any technical issues, please use the same chat window to contact me, and I will try to help you the best I can. And now, without any more delays, I would like to leave you with this amazing session by Sean. Sean, the room is yours.
All right. Thanks so much, Frank. Thank you, everyone, for being here. And thanks for all of the user groups that got together to put this event on and for inviting me to speak to you today about data and database portability in containers. I scratched out the Docker because we're getting more and more into just talking about containers in a more generic sense, not just Docker containers. So I thought I would jump on that bandwagon and do the same. Real quickly about me, I've been working with Oracle Database Technologies since 1995. I started out as an application developer, and then the company that I worked for, the DBAs, quit, and the two developers, we were put in charge of managing the database while they looked for a new DBA, and they never got one. So I consider myself sort of an accidental DBA. I got in and started doing some application database design and started my own consulting company. I did some HA and disaster recovery and site continuity consulting and so forth. Went to work for a company and got involved with database reliability engineering and doing a lot of automation, which led me to begin working with technologies like Docker. And in fact, I started out my first experience with Docker was back in 2014, so almost 8 years ago. And I was initially just mortified at the idea of putting databases in containers. And everything I heard from folks at the time was, don't do this. This is the worst possible thing that you can do with a database, is to put it in a Docker container. And now, 8 years later, it's the majority of what I do is talk about databases and containers and putting Oracle databases into Docker and all the really wonderful and neat things that you can do with the Docker technology. So like I said, I do a lot of infrastructure as code. I write and build a lot of automation. I work with a lot of customers to facilitate that, to integrate DevOps into their database environments. A lot of virtualization, do some work with the Oracle engineered systems, Exadata and Oracle Database Appliance, and so forth. So let's talk about what it means to have portable data. And the example that I want to start with is cloning and refreshing a database, because this is something that as a DBA, you've probably had some sort of exposure or experience with in the past. You have production environments, and then you have your lower environments, and you probably have developers or test teams, whoever it may be, coming to you and wanting to refresh those databases to get them to have some more current data. And of course, the reason that something like that happens is that we'll take that development database, let's say, and we put data in it, and people start working in that environment, and it starts getting messier and messier and uglier, and eventually the folks that are using those databases can't tolerate how far the data has diverged from its original or its starting state. And so we'll say, yeah, we need this refresh data, or we've introduced new features and we want to see how the data looks in prod, and we want to bring it back into that or back into that development or test environment so that we can do more accurate development. So if you want to do a clone, or if you want to refresh a database, of course, we want it to look like this. This is how it should work. You know, a nice, smooth, backing that huge semi-trailer into a skinny little garage. But the reality is that it probably looks a little bit more like this. I've been here where I've just built these kind of odd Rube Goldberg sorts of mechanisms to get things from the database and put it into another environment. And with Docker, you can do this very, very differently. In fact, I would say that you're doing it wrong if you've got these really complex scripts and so forth out there, because what you can do with Docker and how you can make data portable in container environments is really amazing and remarkable, and hopefully it'll alter the way that you view your databases and alter the way that you do things in the future. So to introduce this whole idea, I want to take a step away from containers and look at how Oracle organizes the directories in an Oracle database. I'm going to start by talking about the optimal flexible architecture, the OFA. Hopefully you're familiar with this. This is this concept that if you have, and I'm not going to talk about ASM or anything like that, I'm just going to talk about a regular file system. So if you have a regular file system, ultimately you probably have a directory there called Oradata, something like that. And underneath that Oracle data directory, you're going to have a subdirectory that's your database name. And underneath that, you've got all your control files and your data files. If you're running a multi-tenant system, you have individual directories for each pluggable database. And underneath those directories, you have your data file directories for those pluggable DBs, another directory for your log files, a separate directory for your fast recovery area or your FRA, and again, separate database designated subdirectories underneath that. Everything is nicely and neatly organized for us. And we see kind of the same thing with our diagnostic directory. So if you look at a diagnostic directory, it's got a really similar organization. You've got, for example, here the RDBMS subdirectory, and then there's a subdirectory underneath that for your database, and subdirectories beneath those for each of your instance names. Everything, again, nicely, neatly organized. But this kind of breaks down when we start looking at the Oracle home. It's not as pretty here. Yes, we certainly do have this separation for each of our database versions. So I've got my Oracle home, my product directory. I've got a DB home 1, DB home 2, and so forth, all nicely separated. But if you look a little bit closer underneath those DB homes, well, now we've got a mix of things. We've got software. That's our Oracle home. These are all the files and libraries that make our database work the way that it does. These are the things that deliver the functionality. But mixed in there, underneath DBS and network admin and so forth, there are also configuration files. That configuration affects the behavior of the database, but it doesn't affect the functionality of the software that delivers the database to us itself. So this mix of configuration and software is a little difficult when, or it makes it difficult for us when we want to go in and pull one database off of the system, or pull everything we need for one database off of this system and put it somewhere else. And these are the things that complicate this whole idea of cloning or refreshing databases, and even, in fact, more complex things that we might want to accomplish, which I'm going to talk about a little bit later. So the reality is that when we've got these database environments, or these directories where things are kind of all mixed together, it leads to the potential for us to have mistakes like this, where you go in and you start pulling on one thing because we want to pull this one database off the system, and you end up crashing an entire environment perhaps, or you bring something over to the new environment and you realize, oh no, I forgot this file or that file, and now I've got to reperform my entire migration or take a new backup or whatever it may be in order to copy those files or move those files over. So what we want is something that is going to give us a more direct, more straightforward process. And Oracle databases running in Linux containers let us do that, because we can take a somewhat different approach to this. Now, to understand how that different approach looks, I want to take a quick detour so that we can take a really high-level look at some internals about how containers work. And hopefully this is really fascinating for you as it is for me. So if you've been in one of my presentations in the past where I've talked about Docker, I brag about how fast Oracle databases are in containers. And if you haven't been in one of those sessions, I'll just say it. I can start an Oracle database on a Docker host in a matter of seconds. There's no boot up time for a virtual machine or anything like that. It is just almost an instantaneous process. And I can even create a brand new container that does not exist on my system, create it, and have it start running a database in about the same amount of time. There's no need for me to go and create a database or anything like that. It's really, really fast. And one of the things that makes containers fast is this idea of, or this idea behind how containers work. So if you're not familiar with containers, we have an image. An image is just a piece of infrastructure that we build from code. So we can put the code to build that Docker image of an Oracle database out into GitHub, and anybody can pull that and they can produce an image identical to the one that I build in my environment, or I can create an image and I can share it with somebody else who's also running Linux containers, and they can run it on their system. It doesn't matter if they're using a Mac, a Windows machine, if they're running Linux, if they're in the cloud, or if they're on a laptop. It doesn't matter. That image is going to behave exactly the same way on your system as it does on my system. So we have these images that we build from code. And every time we start a container, we're starting a container by, we'll say, quote unquote, running the image. And every container I run for that Oracle database from that image, it's using the same image. It's not using a copy of the image. It doesn't go out and say, oh, I have this 7 gigabyte Oracle database image. It doesn't take that image and copy it in order to create a new container. All of my databases, they're all using the exact same image. The image is the container. So you're probably thinking, oh my gosh, how on earth can you have, right now in one of my test environments, I think I have 9 or 10 different Oracle databases all running simultaneously, and they're all running the same image. Well, how can I have all those databases running simultaneously and not interfering with one another if they're all using the same image? Well, the secret to this is something called a union file system. And in union file systems, we can reach this idea where we have near zero overhead and no wasted space, and we can put things at extreme densities onto a container host, so that if I've got 10 1 gig images, or if I have a 1 gig image of an application, if I'm running 10 copies of that, I'm not using 10 gig of space. I'm using 1 gig of space plus a little bit extra. And we do that through union file systems this way. So we have a union file system is actually layers of directories on a Linux environment. And it starts out with a base layer. And then there's what's called an overlay layer. And that's where changes to the base layer are written. And at the very top, we've got what's called a diff layer. Sometimes it's called a top layer. It just depends on, I think, where you started out with your Linux or Unix experience. But that diff layer is what the container actually sees. So here's what a union file system looks like when I first start a container. I've got this bottom layer, file 1 through 5, and those are all coming from my database or my container image. And then the diff layer at the top, it just looks down. I like to think of it like looking down through a couple sheets of glass, or glass shelves in a cabinet, something like that. So if I look down from my very top shelf and there's nothing in between, I see file 1, file 2, file 3, and 4, and 5 exactly as they exist on that lower layer. But now if I make a change to file 3, well, that change is written into that middle layer. And when I look down from the top through that top diff layer, that diff layer sees what lies in between the original file 3 and me at that median layer. And so it projects that changed file up to me at that top level. Same thing if I make changes to file 1, if I delete files, none of that is making any change to the very bottom layer. So that image stays unchanged. It's essentially read only. And all I'm doing is making changes at this middle layer. And so when we see this union file system from the perspective of running a container, we've got that container image down at the very bottom. We've got the runtime layer where we make the changes for each individual container, and every container gets its own middle layer. And then the container sees the difference between those two things. And so the container is running at that very top layer. And as long as there's no real change down at the bottom layer, we're not going to change much in that middle layer, which means that our containers, whether it's 2 or 5 or 100 containers, are all pretty much using the same thing down at that very bottom layer. The problem with union file systems is computing that difference between the middle layer and the top layer, or the middle layer and the bottom layer in order to get the top layer is not a free operation. And so we want to minimize the amount of volatility or the amount of change that takes place in the container itself. Well, you're probably thinking to yourself, we're talking about databases here, Sean. Databases tend to write a lot of data and make a lot of changes. And wouldn't that be bad? Well, yeah, they would be bad. So we have this concept called a volume, or a container volume. And just like you would expect here, if we had a container, the whole blue space here, and I've got all my software over on the left, and then I've got my data over on the right. Well, if I was writing that data into the base layer, which would start out empty because I don't have a database in my container yet, and then started putting all my data, would all go into that overlay layer, And then I'd be computing that difference in my diff layer over and over and over again, and the performance of my container would start to drag down. Instead, what we do is we have this idea of what's called a volume. And volumes exist outside of the container, so they're not part of the Union file system. And when we're talking about Oracle database containers, I'm just referencing the Oracle has a repository of Oracle database containers that you can go out and you can freely use. They put all of their data, they create a volume at this /ops/oracle/oradata directory. And that directory exists outside of the container. And so it's not part of the Union file system or anything like that. Now I have my container, and then I've got my volume that's associated with my container. But here's the cool thing. Volumes store data outside the container, but they also persist data outside of the container, which means if I were to remove my database container, all of my data is still there. Well, that's cool because now I can delete my container and not delete my database. But, well, how useful is that if I've got data and no database? Especially when you think about, well, didn't we just talk about this? Didn't we just say there's stuff that's needed by the database, like my OraTab file and my SP file and potentially my listener and tnsnames.ora and so forth. Those are all part of the Oracle home, and those are all in the container. So if you deleted the container, then didn't you just delete stuff that was really important for the database, things that the database needed to have? I mean, yeah, we've got our control files and our data files and redo logs and archive logs and all of that, but it would be nice to have an SP file or an init.ora and listener.ora and all of that so that I can use that database. Well, Oracle does a really cool thing, and I think that this is just pure genius. I think whoever thought this up when they created the Oracle Docker repos was brilliant to have come up with this idea. And it's all based on something that happens when we start a container, when we start it or when we create it. So we use Docker run to create a container. We use Docker start to start a container that's been stopped. Well, there's a thing called an entry point or startup script that runs. And that entry point just runs a script. Real simple bash, well, not a simple bash script, but it runs a bash script. And the bash script goes out and it asks a question. Is there a database here? No. There's no database? All right, well, then the next thing that I want to do is I want to create a database because this is a database container and people probably want a database in it. So if there's no database, it goes out and it runs the database configuration assistant, and a few minutes later, you have a database. But if there is a database, it says, oh, I don't need to create one. I'm just going to start my database. Cool. Except, how does it know whether or not there's a database out there? Well, it looks in this /ops/oracle/oradata directory. And if it goes in there and it says, oh, look, I've got this oradata directory, and then I've got this really familiar directory structure where I've got my database name, and then I've got my control files and data files. And if it's a multi-tenant, I've got my PDB directory and all this stuff. I've got my flash recovery area and my fast recovery area, all of that. That's all there. Hey, great. Hang on a second. What's this DB config directory? We don't see that normally. That wasn't in the slide that I showed you earlier. Here's this DB config directory, and it's got a subdirectory that's my database name. Let's take a closer look at that. What's in that directory? I've got a listener.ora, I've got my password file, I've got my OraTab, SP file, SQLnet, TNS names, all these files that are normally somewhere else on my database. Well, let's look in those locations and see where we would expect to find these files. So let's look in the Oracle Home /DBS and Oracle Home /network/admin directory and see that we're actually doing a little bit of magic here. We're making Docker and Oracle think that something is there that's not really there. And we do that with database, or I'm sorry, not database links. We do that with links in the Unix file system. So if I look in my Oracle home/dbs directory, I see that I've got a password file there, and that password file is linked to this dbconfig directory in my Oracle data volume. Same thing with my network admin directory, where I've got my listener Aura and SQLnet and TNS names. Those are all just linked from their locations in my Oracle software home to the actual files which are saved on the volume. So the answer to this question, is there a database, is answered by going to that data volume that we were talking about before and looking and finding not only the database files, but also all of the configuration files and everything that we need. And as I mentioned before, we've now taken the Oracle Home, the software, the functionality. Those are the Oracle software is what says these are the rules for how you run an Oracle database. We've taken that and we've isolated it and effectively kind of removed the configuration information that tells the database how we want it to behave. So we say your database name is Oracle, and you're going to behave in a particular way by allocating a certain amount of SGA and PGA, and you're going to put your archive logs in this directory and so on and so forth. So that's all behavior. It's not rules for how you run the database. Now there's this cool thing that you can do now that we've completely extracted everything that we need over here in this data volume. Everything we need for a database is there. We have the data and we have all the configuration. So I can do this. I can delete that container and I can start a brand new container, point it at that data volume, tell it your Oracle database SID is Oracle or ORCL, whatever it may be. And when that container starts up, it's going to ask that question, is there a database? It's going to look in that data volume and say, there certainly is. And so even if this container is starting for the very first time and doing what we would normally expect would be to create a database because it's brand new, right? Well, it goes and it looks and it says, no, I have a database. So I'll just start it. And this is what lets us do some really, really neat things with Docker containers so much more easily than we can do it with a quote unquote traditional database. So when we're able to do this, when we're able to completely isolate our database and our data from one another, we're able to start looking at everything as an artifact. And an artifact would be, in a development world, an artifact is an image. So I have my image of a web server or an application server. And this is just a known quantity that I can either create as infrastructure as code, I can put it as an image into a repository, whatever it may be. And I can use these things like Lego building blocks. So if I want to build a database, I need a container host, and then I stick a software installation onto it, and then I stick some data into it, and I have a database. And the data is just as much, or it can be just as much, an artifact as the software home and configuration and so forth of my container or my container host is. So what are the things that we can do with data artifacts or data as code, if you want to look at it that way? Well, that data then becomes something that is versionable. I can treat it as infrastructure as code. I can save that data or the instructions to create that data to a repository. I can distribute it to and from a repository. and I can produce really reliable and repeatable outcomes from that data. And what I'm talking about here is data is created by code. So I have an application out there, and I have users that go against that application, and they enter information, they make requests and so forth. There's code that goes out and manipulates and alters the data in my database. So if I have a team of developers, or if I have a team of quality engineers, and they want to be able to test a process and know whether or not something's working, well, I can give them code. I can give them this nicely saved data set, or I can take a data set, an Oracle database, newly created, run a specified series of procedures against it to insert code or insert data, manipulate data, whatever it may be. No matter how many times I run that process, I'm always going to come out with the same result. So whether I'm treating that data artifact as a huge file that I'm saving all of the information I just distributed, or whether I'm treating it as code where I go in and I tell it, this is the set of instructions that you will follow in order to create this database. Now I have this nice, repeatable, reliable outcome that a QA team or a dev team, if they go in and they run some process against it, they're going to get an expected result from that. And if you're testing new code in this case, and you say, all right, so I've got an e-commerce application, and when a customer goes in and they buy this particular item, they put it in their cart, they purchase it, I should see a certain number of things happen in my environment. They should always happen this way. So I'm going to see maybe a credit card charge go out to a payment vendor. I'm going to see things deducted from my inventory. I'm going to see activity take place in my warehouse. And what's neat about treating data as an artifact is if you have a traditional process where you've got your database and you've thrown a bunch of data into it, you've done a bunch of testing over and over and over again, as that data begins to get dirty, it's harder and harder for those QA teams or those development teams, testers, whoever it may be, to be sure that what they're seeing, the results of their process, it's harder and harder for them to verify that these are, yes, this is exactly what we expect to see. But when you can do things this way, the DevOps way, it's much easier to validate, and you can treat those results with more confidence this way. So we can treat these volumes as an object in Docker. We can manage them through the command line interface. We can use these artifacts in automation, so we can manipulate them with Terraform, Ansible, whatever it may be, Chef, Puppet, and so on and so forth. We can save these objects and the code into GitHub or some other code management repository. It's all very manageable. It's all very visible. It gives us a lot of observability and a lot of control over the system as a whole. So what are some use cases for this? Well, I've already talked about doing environment refreshes where we have this gold image and it's got a reliable known data set. I don't have to worry about that divergence that I was talking about before. We can test for very expected results in these situations. It makes it really easy to clone databases because, well, I just go out and I grab that gold image. And like I showed you before, we have that concept of you just take that data, you put it on a system, you start a container looking at that data, and you have a database. So it's a lot easier to do it this way. And we can also reduce the reliance on the DBAs or your DBA team, because these are all really straightforward file copy operations. we're not talking about going out and running an RMAN restore against something or importing data through data pump. Nothing like that. This is just you copy files, a set of directories from some location, or you run an automation script against some infrastructure as code or data as code sequence, and it produces that for you. And then you just run a Docker container on top of that and point it at that data, and boom, there you go. There's no DBA skill involved in recreating it. Certainly in building the process to begin with, but you can then hand that off to your developers, and you don't have to worry about them coming to you and saying, oh God, hey, do you have time to refresh my database? Here's another example of how portability is really, and this isn't talking about portability in the sense of creating or recreating databases. I'm talking about portability in this case about updating your database environment, and that's for patching. So if you think about a normal patching process, we have a database host, let's say it's running on physical hardware. I go in to my Oracle Home, I load my latest release update. We just got the 19.15 release update that came out for 19C just last Tuesday. I go out and I upload that release update to my database environment. Now I'm going to run OPatch against it. I've got to bring my database or my databases down in order to run OPatch. I run data patch when I'm done. Then I bring my database back, or first bring my database back up and then run data patch. But there's downtime associated with it. And I'm doing this process more or less manually. Maybe you've got some scripting to help you out with it, but it's more or less a manual process that you're running on a database host. And whether you're running in your test environment, your dev environment, stage, or production, there isn't a whole lot of, what's the word I'm looking for? There isn't a whole lot of confidence that you're going to do everything exactly the same way necessarily. But if I have this concept of portable independent data and portable independent software, well, I can just do this completely differently. I can build a database image. Let's say I want a 19.11 database image. Well, I start with 19.3. That's my base installation. I install the 19.11 RU against it. Boom. If I want 19.15, I put 19.3 just like before. And now instead of 19.11, I put the 19.15 patch on it. Boom. I've got a 19.15 database. But I'm not creating a 19.15 database by installing 19.3. and then some other RU, maybe 19.6, and then 19.9, and then 19.12, and then 19.13, and then 19.15 on top of it, where each of those release updates, each of those OPatch installs has the potential to maybe have some sort of conflict. You never know. So my installations are really clean, and I don't have to have downtime for my patch application because I'm building these images out in a completely separate environment. I don't need a database to install database software. I just install it. So I can do that at my convenience. And then all I have to do to patch my database is stop the database, stop the container, delete the container, start a brand new container that's using the new version, point it at my database, at my data, and then run data patch. And everything is up to date at that point. And what's really neat here is I don't have any divergence in my software environment. So my set of instructions, the rules for running my database, the software home, they are exactly identical in every single environment because I'm pulling them from the same image every time. What this looks like visually is this. So I've got my 19.11 home. Maybe I want to upgrade to 19.15. I delete that 19.11 container. I now point a 19.15 Oracle database image at that data, start it, and run data patch. So that database is completely independent from the software that it's using. And it lets me, like I said before, use these things, these artifacts, these individual pieces like Lego pieces. And so I can build a database exactly the way that I want it. Here's another great example. And this is probably my favorite example of how Docker and this concept of data portability and independence of, or independence between data and software is so important and so useful when you're talking about process validation. Again, every database image in every environment is going to be exactly identical because we're using the same image. And that lets us isolate functionality. So remember, function is my operating system and my database software. Those are the rules that say a database works this way. And then my behavior for the database is what I have in my init.aura or my SP file, whatever it may be. The results are just my data. So that is going to be really, really variable. But a database functionally with the same configuration should work exactly the same way on two different machines, as long as those two things are the same. Again, my data may be different, so my results may be different, but as long as we have that functional component and the behavioral component, things are going to work exactly the same way. So what that lets us do with these identical functional components, we're going to get identical results. And so whatever we're doing procedurally has nothing to do with the data. It's only how we perform the steps of the procedure. And so what I'm talking about here is this idea of testing things for really important business purposes, like, can you restore your database? Can you fail over to your disaster recovery site? And so if my production database is an exact copy functionally of my test database or my Docker environment, if it works in my Docker environment, I know that it's going to work in my production environment. And this is something that I think is really important and lost on a lot of folks. I say to folks when I do consulting engagements, I'll say, when was your last successful recovery test? And they'll say, oh, it was 6 months ago. But we've got a procedure. And the procedure, we know that the procedure works. And my counter argument, of course, is, well, there's no such thing as a recovery until you've actually recovered something. A backup is just a bunch of files. And I recently worked with a customer who thought they had great backups, and it turns out that they had an error in their backup scripts, and they were not backing up the control files. So they had 2 years worth of backups that were useless. There was no way that they could have done anything because they didn't have their control files. So if you're not testing those processes, you can't confidently say, yes, we can restore our database. Yes, we can fail over to our other environment. Yes, we can run data guard and switch over in 30 seconds or 3 minutes or 30 minutes, whatever your requirements are. And often the reason that we're not doing that is because of the cost. Oh, well, we would need new hardware to stand that up. Now with Docker, I can do that on a laptop or on a machine, a VM in the cloud. It's really cost effective. The resource requirements are not that high, and you can create analogs of your production environment in those virtual environments, whether it's through VMs, whether it's on inexpensive commodity hardware, using Docker containers to emulate or simulate those environments. So it is a very cost-effective solution in that case. And of course, you have all the benefits, because we're talking about automation here. You have all the benefits of automation: faster, greater reliability, this improved confidence that you have. And of course, automation, depending on how you write it, automation is its own documentation, but automated processes, I find, are more likely to be better documented. And some of the other things you get are this lowered sense of anxiety among DBAs. Who among us as a DBA doesn't just freak out a little bit inside, no matter how confident we may look to everybody outside? Doing a restore or failing over to another environment is I'm always crossing my fingers and hoping that it's just going to work. Please let it work one more time. I love this joke. What does DBA stand for? Don't bother asking. We can reduce team friction if we make it easy for developers to ask the question, can I have a new environment to work with? Or if we just give them the ability to do that, then those developers, the QA teams, whoever it may be, is going to look on us as DBAs as just that much easier to work with and deal with. And their management is going to see us as more cooperative and a more integral part of the software development lifecycle. So a ton of things that you can do with this concept of portability and the way that Docker and Linux containers handle that information and let us separate it, as I said, like Lego building blocks. So with that, I will close things out. Does anyone have any questions they want to share? I don't see anything in the Q&A.
Hi.
Hi.
Hi, Sean. Excellent session as always. I don't see any question at this moment. If anyone has any questions for Sean, please feel free to write in the chat window in your right bottom corner of your screen. Don't be shy. Sean doesn't bite. Right now.
If you come up with something later on down the road, you're more than welcome to send me an email. I will happily answer questions about Docker. My wife will tell you that I never stop talking about Docker.
That's good. No problem. All right. In that case, it looks like there's no one adding any messages or questions in the chat. In that case, feel free, as Sean mentioned, to contact him by email, Twitter, smoke signals, or through us with any questions you have regarding containers and his session 2. Basically, if you are watching the replays, also please feel free to contact Sean at any moment later offline with any questions. I would like to invite you to Sean's next session tomorrow, Autonomous Health Framework. Use your database Swiss Army knife without poking an eye out. This is a workshop that Sean will be giving tomorrow. It's a 90-minute sessions, and I really invite you to don't miss it. It's a fantastic session, as always, with Sean. Sean, saying that, thank you so much for giving the time to present to all the Asia Pac community.
My pleasure, and thank you again for inviting me to be a part of it.
Thank you. Take care, everyone, and look after yourself in these pandemic times. Bye-bye.